Okay, so let's look at the tutorial. Last week we have looked at the some questions related to the ASK, FSK, and PSK, and today let's look at questions related to multi-level. Okay, so for 2A, using binary PSK and multi-level PSK as examples, explain baud rate. Okay, so this actually is already explained in my lecture. So what is baud rate? Baud rate is equal to symbol rate, right? So it's equal to symbol rate, which is equal to bit rate divided by n, right? Where n is okay, log to m lah. Okay, and is the number of bits used to represent each symbol. And you need to use binary PSK and multi-level PSK. Okay. So assuming similar bit rates are used for both PSK and multi-level PSK, let's find the n. So n for binary PSK is equal to 1. So for QPSK, for example, or for PSK, n is equal to 2. If you consider 8 PSK, n is equal to 3. Okay. So if you look at symbol rate, when we change from 1 and equal to 1 to 2 to 3, what will happen to our symbol rate? Okay. For BPSK, for example, okay, the symbol rate or the baud rate. So since the question asks for baud rate, let's use this term. So that is consistent with the question. So baud rate is equal to bit rate. For QPSK or for PSK, the baud rate equal to half of our bit rate, right? Since n equal to 2. So for 8 PSK, baud rate is equal to bit rate over 3. Okay. So yeah. So based on this relationship and values, you should be able to explain lah baud rate for PSK and the normal binary or the multi-level. Okay. So okay, this one is already mentioned last week. Okay, bit error rate also. Okay, illustrate the constellation, signal constellation diagram of QPSK and BPSK. Comment on the performance and advantages of using QPSK and BPS over BPSK. Okay, so this one also in the slide. Okay, the constellation diagram is the this diagram where you can see the phase differences. So for BPSK, so okay, cos omega ct, this is minus cos omega ct. Right. So it's for bit 1, this one for bit 0. Okay. QPSK, you can refer to the it's constellation diagram. Okay, sorry. Okay, 1101 0010. Okay, so please refer to the constellation diagram for QPSK. So you need to draw or sketch these two constellation diagrams, and then comment the performance and advantages using QPSK and BPSK. Okay, we know that the main advantage is in terms of spectrum efficiency, right? Okay, where we can transmit higher bits. So the spectrum efficiency is FP over bandwidth. So for a given bandwidth, you can transmit higher bit rate. Okay, or if you use that's the main advantage of QPSK. So you can utilize the spectrum or bandwidth more efficiently, meaning that higher data transfer for a given bandwidth. Okay, the rest is KFSK, PSK. Okay, and then finally the block diagram. Okay, this last question. Okay, so you're given a QPSK receiver and the input is given as minus sign. Okay, so the input is minus sine omega ct plus cos omega ct. Determine the output at points A, B, C, D, E, and H. Okay, so this is actually from final exam. So you can see the block diagram. The concept is similar, but there are differences. Okay, especially in terms of the carrier reference that we use at the I and Q. For the I, it's used sine omega ct. Over here, it uses after phase shift. Okay, so it's not given, but you know that because of the phase shift, this one should be cos omega ct. Okay, so to answer, the way to answer is very similar to what I've explained in the lecture. You'll multiply the first part with minus sine omega ct plus this one cos omega ct. Okay, multiplied with sine omega ct, and the same thing minus sine omega ct below also multiplied with cos omega ct. Okay, the same steps, exactly the same steps. So based on this, what should you get? Minus sine cos omega ct. Okay. So you should be able to solve. Okay. And then get the answer. So minus sine. This is okay. Try to solve. Okay. If you solve, you should get the answer at okay. So for A, B, and all this, you need to write down the equations lah. For example, this A is minus sign, omega ct plus cos omega ct B also same. And then for D, you need to multiply. Multiply and make sure that you write down in your answer for D all the terms, okay, whether it's DC voltage or the higher frequency components, you need to include in D and E. F and G is when you get rid of the higher frequency components, and you should be able to get F equal to 0 and G equal to 1. Okay, so based on this, okay, based on this arrangement, H should be 1, then 0. Okay, okay, so that's it. There's no more question. So you can see that for this multi-level, also for this radio digital modulation, you should understand that okay, let's look at the mind map that I've shown before we start this chapter. Okay, so we look at you need to know the equations, waveform, spectrum for ASK, FSK, and PSK. So how to generate and detect, and then the bit array performance. And also for this, you need to be familiar with the error function table and also the simplified equation that we use to find the error function. Okay, and then we focus on multi-level shift keying technique, especially we look at the QPSK, and then so we know that within QPSK, the differences between neighboring bits is 90 degree. So we have the general equation to represent the QPSK signal, constellation diagram, and bit array performance of PQPSK, which is similar to BPSK. But in terms of spectrum efficiency, we need QPSK. It's more efficient, but the disadvantage is that it's higher C over N or carrier to noise ratio requirement. And then we also have looked at the generation and detection of QPSK. Okay, so where it's based on the combination of two BPSK signals, BPSK-I and BPSK-Q. And for multi-level, also look at the baud rate. Okay, what is the definition of bit rate, the relationship between baud rate with bit rate, and number of bits. So these are the main concepts or things that you need to understand for chapter 5. Okay, so with this, I conclude chapter 5. Okay, don't forget to answer the review questions and everything. Okay, and then next week we'll have a quiz, for 1 hour. Okay, and then you can have discussion between your groups. The first hour is your quiz. The second hour, I hope you can discuss in your groups to discuss your assignments, both case study and also MATLAB assignments. And only the following week, we'll start with our final chapter, which is multiplexing. Okay. So any question, don't forget to write in your reflection in e-learning. Okay, so with that, Assalamualaikum. Have a very good day and see you again this Wednesday.